Hello everyone, my name is Nyanta and my student ID is 301224927. So the purpose of this lab assignment neural network is to get hand-on experience of the training feed forward network, to experiment with the different size of the training data, to experiment with the different numbers of the hidden layer and to note the effect of the optimization algorithm. So let's quickly move to our exercise question. So the first question is single layer feed forward to recognize the sum pattern. Now let's just move to the coding section. Yeah, here's the exercise number one, which is a single layer feed forward to recognize the sum pattern. For that, we have to create the training data input. So using the NumPy generator, I have created a two set of the 10 numbers which are drawn from the uniform distribution and it lies between the range of minus zero point 0.6 to zero point 0.6 and shape them into the 10 is to 2 uh, n-dimensional array and given the input name as input and my first name Niyanta and store it into the output. Now, using the NeuroLab, I have created two inputs and six neuron in a single layer and a one output. Let me show you the coding part. Yeah, here it is for the six neuron and for a single one output. Now I have trained the data from the above 2 points and set the show value 15 and the goal 0.0001. Now I have to test and simulate the data on the points test value for this is zero point 0.1 to zero point 0.2. Now let's just quickly run the output. So here's the output for the uh, 10 input values and here's my result one this much. So now quickly move to the second question. So our second question is multi-layer feed forward to recognize the sum pattern. Here we have to repeat the step 1 to 8 from the exercise first, which we have done. But in that we have to change the epoch value as well as show and goal. So here I have set the epoch 1000, show 100 and goal this much. Now we have to train the algorithm to the gradient descent back propagation. Uh, okay, so now I'll show you the output for this. Mm, yeah, here's the output for the. Let me move it. Yeah, here's the output for the second result. Now the third question is single layer feed forward to recognize the sum pattern with more than the training. So in this exercise, I have repeated 1 to 3 step which is then rated in the exercise 1 for the 100 random instances and 4 to 8 in the exercise 1. Now I have to I have just yeah. So the result for this is generated for the thousand random instances. It's still going on. Yeah. Here's the output for our result 3. Now we move to our exercise question number 4, which is multi-layer feed forward to recognize the sum pattern with more training data. In this exercise also I have repeat step 1 in the exercise 3. I have created a two-layer feed forward network with the two hidden layers. Let me show you. Yeah, two hidden layers, and we have to set the epoch 1000, show 100, and the gradient this much. Hmm. And I have set the training algorithm to the gradient descent. Now let me show you the output of this. And I have tested to the value of zero point 0.1 and zero point 0.2. Here's the output for the 100 data sets. Uh, Time. Yeah, is the output as well as the graph display. Now move to our fifth question. Fifth question is three input multi-layer feed forward to recognize the sum pattern for more than the training data. For this, I have repeated the exercise one, and instead of two inputs, I have created the three inputs. I have created the three random inputs. So it's set one, set two, and set three, and then concatenate the inputs. After that, maximum and the minimum values for that, both the three inputs, set the gradient. Similarly, which we have done in the exercise one, range from minus 0.6 to 0.6, reshape them into the n-dimensional array. Mm, okay, so let me show you the result. And in this, okay, in this we have to, okay, uh, similarly, we have created the three inputs and test for the result 5. Repeat this exercise and have repeated this exercise 4, but instead of having the 2, I have created the 3 input and result. Check it for the 0.2, 0.1 and 0.2 and record it as a result 6. So let me run this. Yeah, here's the output for our exercise 5, and looking forward, yeah, here's the out result 6 graph and the result 5. Yeah, here's the result 5 graph. So that's all about our neural network assignment. I hope you liked my presentation. Thank you so much.